Hey everybody, in this video we want to solve problem 268, a missing number. So in today's challenge we are given an array of nums that contains n distinct integers in range 0 and n, but one of them is missing and we are supposed to return that a specific number. So for example, if you take a look at this first example here, so we have 0, 1, 2 is missing, and then we have 3. So the answer would be 2, but in the second example we have 0, 1, but since we know already there is a missing one, so it should be 2 because we have everything to that. In this problem, we are only given the array itself. We don't know what is the n value, but is there a way that we can know what is n initially? So the answer is yes, because we know that a range in 0 to n has n plus 1 values, or n plus 1 numbers, right? For example, in this case, if you have 0, 1, 2, and 3, the length of that is 4. So L is 4. So we know that if there were no missing value, we expect to see a list with the length of n plus 1. But since we already know that there is a missing number from this array, so there is one missing, so minus 1. So n is equal to the length of the nums, and we can obtain that by simply just saying that n equal to length of nums. So now we know n. So in order to solve this problem, I'm going with 3 different ways. 2 of them that I want to solve after the first one are more mathematics way, but the first one is more towards a programmatic way that we are wanting to solve. So in Python, you can use sets, and then you can simply subtract sets to find the differences between those two. So now that we know n, and then for the first example, if I just define a set from the range, so simply by saying set over range of n plus 1, I would say y plus 1, so we have 3, and then subtracting that by 0, 1, 3, super fast. By Python, we can just remove anything that's repeating in both sets and just find the difference in those two sets. So let's define a diff set equal to set of range of n, but we know that range in Python is not inclusive, and since we want to include n itself as well, I put a plus 1 here, minus a set of nums. So here we are converting nums into a set, and we are creating a new set of from everything so that there's no missing value, and then by the difference between those two sets, you can just return diff set dot pop, and that would be everything for the first way. Okay, so if I try other ways, the second example, and let's submit at first. Okay, this is the first one. But the problem is, considering the runtime, we are repeating twice. So first of all, there is something that we are creating, iterating through the range from 0 to n and creating a set. And again, there's 2 ONs at the order of n. And then after that, we are subtracting the sets. That should take another ON, so it's not very efficient. The other way is that, again, we know that if we iterate through the, let's say, instead of finding the sets and then subtracting the sets, in mathematically consider that if we compute the sum of the numbers from 0 to n, so 0 plus 1 plus 2 plus 3 in the first example, and then also compute this, the sum of the values in this array, it took the order of n. We are just iterating through that. So minus 0, minus 1, and minus 3. So these are removing themselves by simply subtracting. And then we're left with 2. So the second solution is we compute the sum of range of n plus 1. Again, range, because Python is not inclusive when you're using range, minus the sum of nums. And then you can return that. There it is. But again, the problem is we are now removing an order of n by removing the sets. But again, we are creating a range in creating a phony range and computing the sum, but we can already mathematically know what is the sum of the numbers. So we already know that the sum in integer numbers, like 0 plus 2, 0 up to n, it is equal to n times n plus 1 divided by 2. And it is always a even number, and it is divisible by 2. So for example, here n is 3. So the sum without 2 should be 3 times 4 divided by 2 is 6. And then after that, we compute the sum from this one minus 4 is 2. So instead of using this, I can say n times n plus 1. So it will be computed in order of 1 instead of ordering n, divided by 2. So we can compute this in O1. And we are iterating through the array only once, so in ON. If I submit that, there we go. So it did run faster. So it was everything for today's challenge. It was a relatively easy problem, but we see 3 different ways of solving this problem.